room.
Oh.
Yes, and
I'll share the presentation.
yeah, and then we are live now. Okay, because in my opinion, it's better to start a little bit earlier.
Okay.
And then after the participants can join us. So hello to our first participants. The room is open for you, and we will wait some minutes to start with our webinar. So let us wait 2 minutes, 2 more minutes, and then we will start with our webinar. Okay, so I think we should start now.
Okay.
Yeah, okay, Damien. So welcome to our webinar today. My name is Susanne Kollmeier, and I will guide you through this webinar. I'm the moderator now. Yes, our topic today is efficient handling of food waste and byproducts. In this session, our expert, Damien Clifford, he will explain how SEEPEX pumping systems shop and pump food waste in a single operation. This sounds very interesting to me. Hope for you too. And yes, one short note from my side on the procedure. So please use the Q&A part to send us your questions, your comments, and we will collect them. And at the end of the presentation of Damien, we will answer your questions. Okay, so then I would like to hand over to Damien now.
Okay, thanks, Suzanne. Yeah. Hello, everybody. My name is Damien Clifford. I'm the business leader for SEEPEX UK. I'm pleased to spend 30 minutes or so just presenting the solutions for food and beverage waste handling. So what I'd like to cover this afternoon is give a very brief overview of SEEPEX, the company, some technical description of the progressive cavity pump, a little bit of detail about the products that we handle, so low viscosity, high viscosity pumping, our engineered solutions, so that's where we've taken our standard product range and developed it to suit a certain application, and then to finalize with the look at some applications in each market sector. So overview of the company. So SEEPEX is a global leader of the manufacturing of progressive cavity pumps. We're a German company, headquarters in Northwest Germany, with manufacturing sites also in the States and in China. Globally, we're represented by subsidiaries like ourselves, SEEPEX UK, SEEPEX France, SEEPEX Inc. And where we're not present with a subsidiary, then we have a network of dealers or agencies. So what do? We're specialists in pumping and macerating technology and support these products with our bespoke control systems. And as mentioned, and as I'll go into more detail, for handling of a variety of different fluids. We're part of the Ingersoll Rand group, so a major global corporation. So this opens up our opportunities to supply more than just progressive cavity pumps, so compressors, blowers, dosing pumps, etc. As I mentioned, we're represented globally from the SEEPEX point of view, with a number of subsidiaries, and then with agencies and dealerships across the world. So to the content, the progressive cavity pump, I'll call it a PC pump from now on, if that's okay, because it's easier to refer to. So within the pumping families, there are two sections, the dynamic pump and the positive displacement pump, which is where the SEEPEX pump sits. We're a rotary pump. We have a single rotor turning within a stator. So we share that group, if you like, with the vane pump and screw pump. So the important thing is we're a positive displacement pump. So for every revolution of the rotor, we deliver the same volume of liquid or product. To give an idea of how the pump works, we have a rotor that rotates within the rubber stator as an interference fit. So as the product enters the rotor and stator, the sealed cavity progresses the length of the pump, hence we call it a progressive cavity pump. Because of the interference fit, we can deliver a very accurate flow, very little pulsation, and also with very little variance in flow if the pressure acting on the end of the pump changes. So some of the advantages of the progressive cavity pump is with very low MPSH requirement, with very low shear pumping action. So if we have, let's say, an oil in water mix, we don't emulsify that. Very accurate flow, as well as being able to handle flowable and non-flowable products, which I'd like to expand on as we go through this. So our flow rates start below 0.1 litre an hour, up to 500 meters cubed or 500,000 litres an hour. Our standard product range takes us up to 48 bar, and then we have another additional product range that takes us over 140 bar. A wide range of temperatures. Viscosity is from a well-flowable product of less than 1 centipoi up to a non-flowable product. We can also handle products with a gas content, So the PC pump does not gas up in the suction casing, so we can handle a 98% gas fraction. One of the major advantages is we're capable of a suction lift, so we're a self-priming pump, as well as being able to handle the discharge pressure, so it makes a very versatile pump for most applications. So to talk more about the products for handling different viscosities and reducing solids, not all of these products are used within the food and beverage industry, so I'll give a complete brief overview of the whole product range. So this is our standard liquid handling pump. So anything that's flowable, this would be our first choice. And then a development of that is our smart conveying technology pump. So this is a maintain in place technology. So no requirement to remove any suction or discharge pipework. And it's also an adjustable pump, so we can extend the life of the wearing parts. Following from this, we've got our CS range. So this is for hygienic applications. So it complies with EHEG regulations and FDA 3A. So used for food production handling. So maybe within a yogurt plant or something like that. And then we have a range of metering pumps. So again, the same rotor and stator design, but in miniature form. So handling very low flow rates. So within the food and beverage industry, this could be additives such as flavors, colors, chemicals. And then probably more interestingly, we have a range of open hopper pumps. So as the product becomes more viscous and more difficult to handle, then we introduce a rectangular opening and then an auger feed screw that pushes the product into the pumping elements. Along with these, it's complemented with a range of macerators. So these are designed to reduce the solid size of any product. So this could be before the pump to protect the pump, or after the pump to further process the product for further handling in the process. And then we have a semi-submersible pump. So the rotor and stator at the bottom here is submerged in the product, and then the product is drawn through the pump. So if you've got a very, very high suction lift, more than 10 meters or so, then this pump is ideal for that application. And then all these products are supported by our digital solutions. So we're monitoring the monitoring pump performance and the process performance, so we can alert when there's a deviation to that performance, and when maybe pump needs adjustment, or where a damage may be occurring and somebody needs to attend to the pump, and that's all done remotely. So more detail on the product range. So as I said, this is our standard liquid handling pump, flange inlet and outlet. We can run in either direction. So typically the top entry would be the inlet, and then this would be the discharge. As I mentioned, the further development of this, about 10 to 15 years ago, we introduced the SCT pump. SCT stands for Smart Conveying Technology. So the functionality of the pump is the same, but it's adjustable and can be maintained in place without removal of any pipework. And then the adjustment means that you can extend the service life of the pump. I'll just run a quick animation here. So here's the pump. If you want to dismantle it, you just undo the 8 nuts, and then you can remove the 4 adjusting segments. This exposes the rotor, the stator, which is in 2 parts, so that can be removed. And then also the rotor can be simply removed without removing any pipework. So you can maintain the pump very, very quickly, saving approximately 85 to 90% of the normal maintenance time that you would have for a progressive cavity pump. But one of the major advantages is that when you have wear inside the pump, you can easily adjust it by a quarter of a turn of each nut, which will bring back the interference fit between the rotor and stator and reinstate the pump performance and efficiency. So further development of the standard range of pumps brings us on to the open hopper pumps. So as I mentioned, as the product gets more viscous or thicker, then we introduce a range of hopper designs and auger feeds so that we can handle more tricky products. So the first of this range would be with a small square hopper. So the product is viscous but still flowable. The auger within the pump here just assists the product into the rotor and stator. Then as the product becomes more viscous, or the product range becomes more viscous, we have a larger hopper with a larger auger. And also we introduce this area here, which we call the compression zone, which then guides the product into the rotostator entrance. So again, this would be for a less flowable product, a thicker, more difficult product to handle. And then moving on from that, where we have products we want to handle which have solids in, then we include a set of knives within the pump. So if you were to put a bag of potatoes, for example, in the top of the pump, you could pump them through. They'd be chopped before going into the rotostator. This just shows in more detail the fixed knives on the rotating shaft and the fixed knives on the inside of the pump casing. So typical applications, fruit, vegetable waste, poultry, fish, basically anything that is large solid size can be cut and then pumped for further processing or to reduce waste volume. So again, as the product gets even more difficult to handle, we change the hopper design. So we have vertical sides of the hopper with a very large auger with a big pitch, so we don't have any bridging over the auger itself, and the product is guided into the rotostator, as shown in the animation. So you can see the auger runs on a liner, so it's cleaning the sides of the hopper, so it's avoiding any bridging over the auger. And the size of the pitch means that we don't need any bridge breaker above the auger to push the product into it. It drops straight through. So this could be used for any highly viscous product or any non-flowable product. So where product's non-flowable, we need to overcome quite high pressures within the pipe. So you result with quite a long pump with quite high power requirements. So to overcome this, we introduced to the market about 10 years ago what we call SAI, Smart Air Injection. So here we're combining the open hopper pump with an air compressor, and then sometimes we will use a small dosing pump to add some lubricant into the pipe just to reduce the pressure that's required by the pump. As the pump starts to put the product into the pipeline, we have a very short injection of air, a number of seconds every number of minutes, and then this effectively forms a slug of product which is then pushed down the pipe. So the net result is you have a smaller pump with a smaller motor, lower whole life cost because of reduced power consumption, and because it's smaller, it's easier to maintain. I'll run a quick animation here. So we're measuring the level in the hopper here with this typically radar or laser. As the product drops into the pump hopper, the pump starts slowly, and then as the level increases, then the pump speed increases to clear the hopper. And then as the product goes into the pipeline, we sometimes, not all the time, inject some liquid just to lubricate the outside of the pipe, inside of the pipe. And then as the pressure increases, here in this case to 3 to 4 bar, a very short injection of air is employed, which forms a slug, and then that's pushed down the line. So to complement the pumping product range, we have a range of macerators. So these can be before the pump to protect it, or after the pump to further process the product to reduce the solid size, so that it can be more easily handled. So that's our standard range of products. What we've done in the past is used our experience with those products to apply them to new applications. So the range of our engineered solutions. So we have in every case we have the same rotostator design. So the pumping element is the same. It's just different how we get the product into those pumping elements. So the first example here takes our open hopper pump design with an auger. This auger is feeding a grinding mechanism, and then this is dropping into the discharge pump, which is then taking the product down the line. So typical application that we developed this for actually was to handle mango stones, which aren't flowable, and their size limits how you can handle them. So these are ground and then pumped. So the main advantage to the customer here was to remove the movement of bins through the factory, going from the high care to the waste area and vice versa. So further development on the open hopper range, we've got the auger feed screw here. We've got the set of knives, so anything coming into this pump gets chopped, the pumping elements, but also if we've got a very sticky product or like a dough, then we do have a bridge breaker here which forces the product into the auger to avoid any bridging. And again here the same principle, but here we're coupling two pumps together with a very large storage above, so then we can increase the storage and reduce the number of times or the time that the number of times the pump has to start and stop. And again here, you note here again the same rotating elements, pumping elements. So here this was designed to suit a salad processing plant where the waste product, the leaves, etc., were entered into a water flume to be transported through the site. Here we employed a solids collection area because there's inevitably stones and knives and this sort of thing in the product, so they drop out, and then the lighter parts that we want to handle float, and this very large auger pushes the product into the pumping elements. And then using a number of different SEEPEX technologies here, this open hopper drops the product into an auger at the bottom here, which feeds into a macerator. So we're reducing the solid size before it enters the pump, and then the standard pump is then taking that product away. So those are the engineered solutions. I'll come on to now how we apply the pumping technology to different applications where you may not think of a progressive cavity pump initially. So here we got a very typical example of using the BTM pump, so the pump with the knives. We've got whole fruits, mangoes, oranges, apples, whatever, and then they go into the top of the pump. They get chopped and then pumped. So here's an example of what that waste product might look like. So with it being chopped, it takes up less volume. So then you reduce your movements either within the factory or your road traffic movement. Again, here an example where we're handling waste potatoes. This is in a plant that's making chips. So potatoes that are rejected or too big or too small or whatever. Again, they're pumped through the knives, and then we have effectively a slurry which is taking up much less volume. And again, here with one of the advantages of a pumped waste handling system is the pump can sit in the high care area and then move the product into the waste handling area of the plant. So here you can see a chopping table, peeling table. Any waste product is thrown into the top of the pump. The pump chops it and then pumps it away. And you see here it takes it out into the waste handling area, in this case lorry skips. Whereas normally you might have had a vehicle movement or even a person moving around the site with a bin and then coming back into the high care area. And again, here an example of a closed system. So this is the example of the auger feeding the grinder, and then the product going into the pump here and then pumped away. So here we're handling peelings and reject melons and that sort of thing, and you can see how the bin is just lifted and tipped into the top of the hopper. Another application. So here we're inside a crisp factory. So previously, reject crisps would have been detected, dropped onto this conveyor, and then dropped into some sort of container or vessel. Then this would have to be moved into the waste area. Again, you can see there's crisps on the floor there, so there's oil and health and safety hazards. So what we did, we put a pump at the end of the conveyor. So the pump is then taking the crisps away. They're then reduced in size, they're compacted. So then we're ultimately moving a lower, smaller volume of product. So again, saving the transport costs, saving the health and safety vehicle movements, etc. And here back to the water flume pump again. You can see here we've got the waste, the type of waste that's being handled, and how it looks after it's been through the pump. So you can see, or you can imagine the volume reduction, and then the cost reduction in terms of dealing with a waste product. And here for a highly viscous product, here we're within a soya milk production facility. So the soya beans are boiled, and then the liquid taken away for the milk, and then the final product is put through a centrifuge, so dewatered, to be a non-flowable product. So this is actually a trial that I did. You can actually stand a spade up in that product and it won't fall. So we're handling a completely non-flowable product. And you can see here, maybe this is how it would have been handled before. One of these bins would have been under the centrifuge, wheeled out into the waste area, and then back in. So chance of contamination of the high care area. And then on the sort of agricultural side, so here we've got a pump at a tomato growing site, and the waste vines are raised up via conveyor, dropped into the pump, chopped, and then pumped away. And this end product actually goes to a biogas plant where a certain size of solid is required, so it's ideal for that application. Now moving into the poultry and meat area of the food and bev business. Again, within the poultry market, there's applications for reject chickens, entrails, dead on arrival birds, and this sort of thing. I'll just briefly apologize for the next slide, it's a bit gruesome. But you can see here what we're doing. We're pumping the product into a sort of paste, and then potentially this paste can go to a food, typically like a pet food application, or actually what we can do to stop the product going back into the human food chain, we can also, with one of our metering pumps, inject a dye so that it's colored and it can't re-enter the food chain. So here again, this shows that application where we're dropping the product into the top of the pump, macerating, then pumping it. And this goes from this clean area into another area where the product is frozen and prepared as pet food. Within the brewing industry, so brewing and distilling, the byproduct of the brewing and distilling industry is spent grain or draff. So this is after the product's been made. This is a ground grain which has been soaked, so it looks like it wouldn't flow if you look at it in the guy's hands, but actually we can pump it with in this case with a very large open hopper pump. We're taking the product directly from the distillery in this case, and we're pumping it over 500 meters to a biogas plant. So you've got a completely sealed system, no road transport to move the product quite a long distance, and directly into the further processing area, in this case to generate biogas and electricity. Also, within the bakery industry, we can handle rejected bread, rolls, this sort of thing. We can handle also dough. In this case, this is rejected dough, something wrong with it, and we were able to pump that away. And within the processing plant, again, dough can be quite a difficult product to handle, so it's very sticky, not flowable. But in this case, we're able to load it into the top of the pump and then pump it into whatever vessel we need to alter. So very high viscous products are easy for us to handle. And again here, we've got reject bread, reject dough. We can be mixed together and then pumped through. Now within the convenience food area of the market, huge market, as everybody's aware. there's a lot of waste food, but there's also rejected food which has already been packaged. So if the label's not straight or whatever, then it's waste. So we developed the pump range again, so we can take either the rejected food or the complete packaged convenience food. So here again, it goes into a bin. The bin's dropped into the top of the pump, and then we're chopped with the BTM pump, and then macerated, so it can then go to for biogas production. So biogas then produces energy. So again, you can see a better view of the pump here. So we've got the macerator there, which is actually after the pump to reduce the solid size to a few millimeters, so that it can be used within the biogas industry. Now within the fish industry, there's wastage there with preparing fish, so heads, tails, frames. So our range of pumps here. So this one, for example, is in a sardine filleting factory. So there'd be waste fillets and frames and various waste things. So again, loaded into the top of the pump and then pumped in a sealed system. So again, there's no spillage or smell or anything else into the waste processing area. So this gives you an idea of the sort of thing we're handling. So we've got some fillets and frames there. Again, going into the pump and then pumping away, and no additional water in any of these applications. So that brings us to the end of the overview of the product range and the engineered solutions, and then where these solutions are employed within the industry. And so just to summarize, what we're trying to put over here is that we have a means of reducing waste volume. So then that reduces the disposal cost by reducing the road transport or eliminating road transport in some place. We have a range of pumps that can be clean in place, so for food production applications. And really, our range of technology can prepare the waste product for the next phase. So it could be biogas, or it could be transferring into another food source. So I'm hoping that was of interest to you, and yeah, I'll take any questions if I may.
Okay, thanks a lot, Damien, for your presentation. Okay, let us wait a moment for the questions which maybe arise. Let us have a look. Okay, to all participants, so please feel free to send us your questions, and please use the Q&A part, the chat. Okay. Damien, we have one question regarding the CIP. How do you CIP the pumps? So do they need to be bypassed, and how do you calculate the flow that should go through them?
Okay, yeah. So yes, our Hygienia range of pumps, they do have a CIP connection, so clean in place. So with your changing product or between batches of products, you can put a hot product through with chemical into the pump to clean it through. Yes, the pump is partially bypassed, so we use a higher volume of CIP liquid, and then we run the pump very slowly just to allow it to clean through rotor and stator without affecting the pumping elements, because we've obviously got a hot product going into a cold pump. And in terms of calculating the CIP that's required, we would engage with the people building the plant and just work together with them to understand how much liquid's used. And then typically the CIP liquid is introduced to the pump by some other pump technology for high volume, no pressure.
Okay, so thank you for the answer. Another question we have: does the macerator have different knives for different end sizes, or is this one set, or one set is the standard?
Yeah. So the size of solid that we macerate to is determined by the size of the holes in the shear plate that the knife passes over, and the speed at which we run the knives. So if we run the knives more quickly and we have smaller holes, then we can reduce it to a smaller particle size. Or if we don't need a very small particle size, we can leave larger holes and run the macerator at a normal sort of pace, normal speed.
Mm-hmm. Yeah, thank you.
Thanks.
So let us wait maybe a moment. So currently we have no more questions so far. Yes, there is somebody who raised his hand, so please use the Q&A part to fill in your question. Okay, so currently we have no more questions, but nevertheless, I think all participants, they can get in contact with you if they have questions afterwards. To all participants, you also will get the recorded session from our side after this meeting. So please feel free to contact us. Then I would like to say once again to you, thank you for your attention, for your patience. And yes, I hope we will see us soon in another webinar. And I wish you, yes, a good morning, good afternoon, wherever you are. And I hope we will see us again. Okay.
Thanks, Suzanne.
Yeah, so thank you and bye-bye. See you the next time.
Bye.
See you. Bye-bye.